All right, today we're going to work with graphing logs, and we're also going to talk about the natural logarithm. We've learned about the letter E. And we said that E, just to review, was approximately equal to 2.71828. It was a number, just like pi is. All right? And we also talked about the function e to the x, the exponential function e to the x. All right? Well, the reason why that's important, you remember that we've said that the inverse of an exponential function is a logarithmic function. Well, if you see this, ln of x, okay, and that button is on your calculator, that is actually what's considered the natural log, all right? And it is log base e of x. So when you see that ln button on your calculator, it's not log base 10, it's log base e, all right? And once again, it has to be greater than 0, okay? Now, we're going to talk about the relationship between the natural log of x and e to the x in a minute. But it's a very important relationship. These two are inverses of each other. All right, and we'll talk about that some more in a minute. But first, let's do some basic problems, just understanding some properties. Let's say you are asked to write something in exponential form. Write in exponential form. And let's say that it is the natural log of 20 equals 3. Something like that. Okay, you'll have some of these in homework. Very easy. The first thing you have to do is rewrite it as log base e of 20 equals 3. That's the first step. And then you just do the switcheroo. All right? It's e to the third equals 20. All right? And we've written it in exponential form. All right? Pretty easy. You'll have some of those tonight. You'll also have some where they ask you to go the other way. They'll say, write this in log form. So they'll give it to you in exponential form, like e to the fourth equals 54.6. They'll give it to you in exponential, and they'll tell you to go to log. So here's what I do. Is I just set up my little blank log and equal sign. This is what I do. And then I just kind of do the switcheroo backwards. E to the fourth equals 54.6. Now, what is log base e? What did we say log base e is? The natural log, or the ln. So technically, I could write this as ln of 54.6 equals 4. Okay? Then they'll ask you to evaluate without a calculator. And all we're going to do is use the properties once again. Evaluate without a calculator. Let's say they give you the natural log of e to the fifth. And they say, okay, find out what that is without a calculator. Well, once again, we're going to use the switcheroo. Once you get it set up this way, then all we have to do is say, okay, this is log base e of e to the fifth equals what? And then we just do the switcheroo. All right, we start here and we work around. We're going to say e to what power equals e to the fifth. And of course, that's going to be 5. So my answer is that the natural log of e to the fifth is 5. And that's actually a property that we're going to talk about later. If I have log base e of e to whatever power it is, it's just going to be the power. Okay? It's a nice little property. So you'll have some where you have to evaluate without a calculator. And then they'll give you some where they say evaluate with a calculator. And of course this will be very easy. If they give you the natural log of 2, then we get to use our graphing calculator. And over on the left-hand side, you will see the ln button. So you press the ln button, and we said we were doing the natural log of 2. So the natural log of 2, put my other parentheses, hit enter, and there's your decimal. Okay? So we don't need to do any more of those, but that's how you do it on the calculator. You use the ln button. So that's 0.693. Okay? Now, the next thing I want to do is I want to talk a little bit about graphically. Okay? Graphs. Here's what I want to do. I want to look at two functions, e to the x and the natural log of x. Okay? So if we want to do that, there's several ways that we could do it. We could just go ahead and graph them and look at it that way. But I want to start by looking at the table. So let's go to the graphing calculator. And let's go to our y equals screen. And first, let's do the one that we've already worked with, e to the x. So that's second ln of x. Okay? And let's go to the table setup. And why don't we just start at about -3 and go up by 1s. All right? And we'll just do this one automatically. We won't do an ask. All right? Go to your table. So there's our values. Okay? There's our values for the exponential function. We can see it growing, of course. So here's our values. And like I said, as we move along, okay, we can see this thing growing. All right? Now, let's now do this with the natural log function. So let's go back to the graphing calculator. Let's go to my y equals screen. And let's change this. I'm going to clear this out, and I'm going to change this to the natural log of x. Okay, and I'm going to leave the same table set up. So let's go now to my table. There's a bunch of errors up there. Bunch of errors. Wonder why that is. We'll talk about that in just a minute. Okay, so there's the table for the natural log function. Okay? Now, if we look at these graphically, okay, let's go ahead and go to the graph. All right, we'll go ahead and go back to the graphing calculator, and we will just do zoom standard and look at the graph. There's the natural log function. Now, we probably don't need all of these negative x's over there. So why don't we go to our window and close it down to -5 and maybe only go to +8, just so we can see it a little bit better. All right. Now, let's add in e to the x. So let's go back. Let's leave that as our y1, and let's add in e to the x. And what is the line of reflection for inverse functions? Isn't it y equals x? Let's go ahead and add that in. And let's just see if these two are inverses of each other. All right? And then we'll hit graph. There's ln, there's e to the x, and there's y equals x. Those two are inverses of each other. All right? So that's a very, very important concept. You need to sketch that graph in your notes someplace and label these. This is the graph of ln of x. This is the graph of e to the x. And right in between, we have the line of reflection, y equals x. All right? Somewhere in your notes, you need to have that the natural log of x and e to the x are inverses of each other. Okay, very important relationship between those two. All right. Now, one of the other things you're going to be asked to do tonight is to work with transformations of log functions. All right. So, you know, if just real quickly, if I was going to look at the function log base 10 of x, and then I was going to look at a new function, log base 10 of x minus 2, we've learned about transformations. All right? And remember that we said that log functions, instead of going through 1 on the y-axis, they go through 1 on the x-axis. So here's the graph of log base 10 of x. And by the way, the natural log function does the same thing. It goes through 1. So if this is the graph of log of x, what do you think is going to happen with this one? Where's it going to go? What have we learned about transformations? It's going to go 2 units to the right. All right? So it's going to go through 3. This would be log base 10 of x minus 2. Notice something. There is a vertical asymptote right here at x equals 0. Okay? I cannot take the log of a negative number. And that's because of the way it's defined, using the switcheroo. Okay? There is no way, I told you that I would explain that, the error that we saw. If I have log base 10, all right, and let's say that this was -5, and I had some power here. Do the switcheroo. There is no way to raise 10 to a power and get a negative number. You can't do it. You cannot raise a number to a power and get a negative number. That is why when you look at the graph of log, why it doesn't exist over here. Okay? It's not in the domain. All right? And we're going to stop there for today.